Hi, everyone. Welcome to From Concept to Creation in Azure AI Studio session of the Scottish Summit 2024. I'm Carlotta Castelluccio, and in this talk, we're going to put into some practice some of the concepts you might have heard already while attending other previous sessions about generative AI. But we are going to focus on the Azure AI platform, and we're going to present some hands-on demos on how to leverage it to build your generative AI solution. But before doing that, let me just thanks all the sponsors that made the Scottish Summit event possible. And of course, also thank you all for joining the event as attendees and watching this session. And just a quick intro about myself, just a few words. I'm a cloud advocate in the AI advocacy team at Microsoft. And it's been now a few years that I work in the AI field at Microsoft. I started as a field engineer supporting customers in building conversational solutions, so chatbots and voice bots. At a time when building a chatbot wasn't as easy as today, and I would say also as cool as today, by using traditional language models with predefined entities and intents and several lines of code to get the bot coming with basically a predefined script as an answer. So if you know what I mean, you can probably feel the same enthusiasm I feel for everything around generative AI and large language model. I'm a public speaker and technical writer, and my mission is to help developers make the most out of Microsoft AI technologies and building innovative solutions responsibly. So let me start with the current AI landscape and with some numbers that depict a clear framework of AI usage today. In fact, Microsoft and LinkedIn have recently published the 2024 Work Trend Index annual report, looking at how AI will reshape work and the market broadly, interviewing more than 30,000 people worldwide and analyzing data from hiring trends on LinkedIn and Microsoft 365 productivity signals. Among all the insights you can find on the report, I found quite relevant the 3 points highlighted in this slide. So first of all, 75% of global knowledge workers use AI at work, which means use of generative AI has nearly doubled in the last 6 months. 79% of leaders worldwide believe they need to adopt AI to stay competitive, but most of them are worried about a lack of vision in their organization to implement it. And last one, which is particularly impressive to me, 66% of leaders worldwide declare they would not hire someone without AI skills, and even a higher percentage would hire a less experienced candidate with AI skills rather than a more experienced one without them. So that's the kind of landscape where we sit in today. And in this context, I want to propose you this demo scenario for our practical applications today. In this session, we are going to use a real-world example to highlight the concept we are introducing. So let's imagine we are a developer for the Contoso Outdoor Company, which is a fictional leading e-commerce company that sells outdoor gear and equipment. Contoso is working on a new website design, and we have been tasked with generating text copies and code snippets for the website. We have heard about the power of generative AI models, and we want to explore how we can leverage them to generate content for the website. Well, to address this scenario and build our generative AI solution able to help us with the website design, I think we should look no further than the Azure AI platform, which provides us with the best-in-class AI foundation models, and it has everything we need to build our AI application safely and responsibly. And as a response of the AI paradigm shift and the huge wave of innovation of recent years, the Azure AI platform has been recentered around the Azure AI Studio, a hub unifying all data and AI services in the Microsoft Cloud. And it includes all the Azure AI services you might know already, designed for specific domains like speech or vision, which what we used to call cognitive services, basically. It includes Azure machine learning features like the foundation model catalog offering and the prompt flow tool, and it provides us with actionable tools to safeguard our system against latest threats and operationalize responsible AI principles. But Azure AI Platform is more than that, because Azure AI Studio sits in a larger AI tool chain that makes integration seamless for familiar open source tools and frameworks such as Semantic Kernel, LangChain, and AutoGen. The Azure AI Platform meets every developer where they are, whether they prefer low-code approach with a UI experience, a command line interface with the Azure Developer CLI, or a code-first experience. Also, it stands by developers on the whole end-to-end lifecycle, in the ideation phase with open source project starter templates, in the building phase with code-first prompting tool, open source frameworks integration, and powerful tracing facilities, up to deployment and release in production environments. For the sake of this session, we are going to focus on our goal to build our AI application prototype in Azure AI Studio. And Azure AI Studio is generally available to everyone and accessible at ai.azure.com. So if you haven't done it already, I really encourage you to navigate to ai.azure.com and explore at your own pace, but we are going to do a tour in a moment. It enables you to innovate because you can explore the latest and greatest models on the market, to differentiate, so enrich the models with the most relevant and timely knowledge to engage your users, safeguard your system by applying moderation filters and attacks mitigation like jailbreaks attacks, and operationalize your application. But without further ado, let's get started with Azure AI Studio, so with our first demo. So let me jump into my browser at ai.azure.com. And the first concept to grasp when getting started with Azure AI Studio are two concepts, the AI Hub and the AI Project. Here I'm in the hub, my hub overview, which a hub basically provides a collaborative workspace for AI solution development and management. And you need at least one Azure AI Hub to use the solution development features and capabilities of AI Studio. An Azure AI Hub can host one or several projects. Here I've already created a project for this demo. And each project encapsulates the tools and assets used to create a specific AI solution. Basically, a hub enables you to define shared assets that can be used across multiple projects. Other things we can see in this hub overview are the hub properties. So let me go into the hub overview to showcase you all the properties of the hub. So we have the hub properties with, for example, we can access the API endpoints and keys. We can access the subscription quota and other information. We have the connected resources, because Azure AI Studio allows for multiple resources to be connected to Hub, expanding its features and functionality. In this case, for example, we have Azure OpenAI Service, Azure AI Search, Azure Blob Storage, and so on and so forth. And then we have a permission section where we can basically grant access to collaborators or applications. While if we go into the project we have inside the Hub, we can get started with our Azure AI Studio tour. In fact, you might have noticed that our left-hand bar menu has been updated with some additional tabs, which represent functionalities tied to my project. But the main section I want to present are the Get Started section in here, where we can discover the capabilities of the pre-built models available in the Azure AI Studio. And specifically, if I go into the model catalog, this model catalog provides 1,700 and more open source and proprietary models in the studio. And we can find, the best models for our needs by, for example, selecting among several model providers. We can also filter by license, for example. We can filter by inference task, deployment options, or we can directly type, of course, the name of the model we are looking for into the search tab. For example, I can look for the 5.3 mini model, which is one of the latest addition to the small language model collection of Microsoft Research. And once I click on one model that I want to explore, I get what we call model card. And by going, which is the presentation basically of my model, and by going through this model card, I can learn about the training data set, the intended use cases, the deployment options, and so on and so forth. And I can also try the model out before even deploying it with this handy playground. Another thing I want to showcase of the Get Started section is section is the model benchmarks. In fact, we have almost 2,000 models available in Azure AI Studio. We need a way to compare benchmarks across different models. And the cool thing of the model benchmark is that we don't have to upload a dataset because there are multiple datasets available. So you can compare the models against those datasets available, and you have also some visualization of the benchmarks against some predefined metrics like accuracy, coherence, groundedness, and so on and so forth. And now, the next section is the project playground section, which is where you can basically interact with the GPT models you have deployed your subscription through the Azure OpenAI service. And each option in here represents a different approach to interact and using AI models. And each playground mode is designed for a specific use case. For example, the images playground is designed for image generation task with DALL-E-free, while the completions playground is designed for text generation task. And in addition to that, the chat playground allows you also to create a quick prototype of a multimodal copilot, so a large language model-based solution that you can customize, evaluate, and deploy as a web application. We are going to use this playground in the next demo. But for now, let me come back to the deck because we have explored the platform so far, right? But if Microsoft makes the platform, you as developer definitely make the difference. Which means that starting with powerful models is key. And we have seen how broad the offering in the AI Studio is and how to leverage the studio to find the right one for your project needs. But your input to the model makes you tailor your model selection for your specific needs and users. And yes, we are talking about prompt engineering, because prompt engineering is the process of designing the model input to deliver consistent and quality responses. And there's a few reasons why you should care about prompt engineering. First of all, generative AI models are stochastic. So for the same input, you don't always get the same output. Generative AI models can fabricate responses. So the model will always give you an answer, but if it doesn't have the context to give you the right answer, because it cannot access the latest data or private data, it will invent an answer for you, which is something you want to avoid, of course. And models do not have memory of previous interactions. So if the model pretends to know the history of the conversation when you interact with it through the playground, it's just because the app built on top of it is passing an input to the model, the conversation history. So hopefully this visualization helps us understand all the components of a prompt, because prompt engineering is a non-trivial task. The input to the model is generally composed by a system message or model prompt, which you use to provide the model with additional context to generate an answer, and the user prompt, which is the actual question or request. The system message usually remains the same for the whole session of interactions with the model, while the user prompt varies at every turn. Now, if we zoom into the system prompt here, this might contain several information. For example, the description of the task to accomplish and the behavior expected by the model, the tone and the style of the answer that we want to achieve, some safety guardrails. For example, we can say to the model, do not cover these topics or decline any request to generate content, harmful content, and so on and so forth. Jailbreaks, mitigations. We can also have some additional data sources that the model should use to ground responses. And we can add, of course, the conversation history. On the other hand, if we zoom into the user prompt, so the user query, this might contain one or several instructions, optionally accompanied by what is called the primary content. For example, if you want to summarize a text, that text will be your primary content. But it can also contain one or several questions. It can contain examples of input and output for the task we want the model to complete. And it can also contain some cues, so a jumpstart prefix that can help the model to generate the desired output. In addition to that, there are some parameters that you can set to tune the model's output, which are the temperature, which controls the degree of randomness of the output generated by the model. A higher temperature will result in more diverse and unexpected responses, but also more creative, while a lower temperature will result in more conservative and predictable responses. While top P parameter is another way to control the degree of randomness in the choice of the next predicted token by setting a percentage of probability where the model should look into. Now, the first best practice in prompt engineering is give your model clear instructions. You can imagine you are speaking to an untrained intern, so you need to avoid assumptions, so provide contextual specificity for the task the model should perform. Break down requests into simpler instructions or smaller tasks, and provide details. For example, define the format you expect for the output and add examples of what you expect. The other key thing here is that all of these is not done once for all. Prompt engineering is an iterative process of trial and errors. And handling refusals is also important. So when the model indicates the inability to perform a task, we can use that as an opportunity for tuning our prompt to guide the model towards a clear understanding. Now, in Azure AI Studio, the chat playground is the best place to start testing and iterating over your prompts, since you get an immediate feedback in an intuitive interface. Another feature which is helpful when working on prompt engineering is the prompt catalog, which provides a list of prompt templates for different use cases and tasks. But let's jump back in Azure AI Studio to see all of these in action. So let me go back to Azure AI Studio and specifically to this chat playground where I have already defined a system message. So our scenario is always the same. So creating a web design UI for the Contoso e-commerce website. And in this playground, what I've done is I've set the chat engine, so the deployment that I want to use as chat engine, which is GPT-4o, which is one of the latest models within the OpenAI family. And it is able to process multimodal prompts and generate an answer accordingly. And then, as I said, I've also specified already a system message with a task that said you are a web copywriter for the Contoso outdoor company, and your goal is to generate the website copy for the homepage. So now let's go ahead and use some basic prompting, like this one. Suggest a tagline for the website landing page. And let's send this to our model. So as you can see, we've got, in a few seconds, we got an answer. And even if I didn't refer to the Contoso e-commerce website in my user query, since I've specified this additional context in the system message, the model is able to ground the response in the context. And it also follows my instructions about the style, because it's using the Contoso name of the brand in capital letters. But now let's do one step further, because models like GPT-4o can generate more accurate and relevant answers if we break down the prompt into smaller parts. So let's try this prompt now, which basically is structured in 3 parts. We are asking to the model to write a short welcome message for the homepage, specifying the company name and the value proposition, a brief description of the business, and then a short description for all the product categories. So like tents, backpacks, hiking clothing, etc. So let's see. Yeah, we're going to wait for the answer. Here we are. So as you can see, the answer this time is longer, and it contains all the sections we have asked for. So a welcome message, a business description, and the information about the product categories. We can get a similar result by using another technique, which is called chain of thought prompting, where it's the large language model responsible for breaking the task down into smaller steps. So, let me jump back here. So I can use a prompt like this one, in which I basically instruct the model to take a step-by-step approach in its response, including all the we need. Bear with me while it loads. We are saying to the model, take a step-by-step approach in your response, including, again, a welcome message, a brief description, and description of the product categories. But this time, we want the model to provide us with the reasoning it used to achieve the response, and then share the final answer in a specific format. Let's see if we can get a response. Let me try to refresh the page. Basically, this chain is always used to break down the task into smaller pieces, but we guide the model to describing what it should do in details. Window. I can open it in another.
Sorry, Carlotta, I'm
system message
in
the system message
the
field.
Sorry, can you hear me?
And then here, let's send again our user query. Which was this one. So response including a welcome message, a brief description of the business, and a description of the product categories, and provide the reason for giving the answer. So let's hope for the time. In a few seconds, I should get the response back from the model. Here we are. So the model is saying, to craft an effective homepage copy for the Contoso will follow these steps. So it's writing the kind of reasoning it will be using to achieve the result. Let's wait a bit more to get the rest. As you can see, it's loading. We've got our response back. So this is the reasoning. The model is, explaining how it is achieving the result, and then it gives us the answer, which is similar to the one we've got before. With all the section we have asked in the welcome message, the brief description of the business, and the product categories description. Okay, and there are also other techniques, like, for example, the few-shot learning techniques, in which you can basically provide the model also with examples that can better steer the model to the desired outcomes. So you put examples of input and output pairs into your user query to guide the model to. All of these are prompt engineering techniques that can help you get the most out of these models. Now, another thing I would like to showcase is multi-prompting, because we have seen some examples for text input, text output kind of scenarios, but prompt engineering is not just about text. So as mentioned earlier, GPT-4o is a multimodal model, which means it can process both text and images. So let's see how it works with the combination of an image and a text prompt. So this time we are using a different system message. So we are asking the model to help us again with the Contoso outdoor company e-commerce website code snippets for page graphical user interface. So what we do here is we are going to upload a picture, which is the sketch node of user interface. Let me show it to you a bit bigger. I know it's an ugly, not able to really draw, but yeah, this is our image that we are uploading for our Contoso outdoor company UI, website UI. And then we couple this with a textual prompt, which is this one. Let me find it. Here we are. Generate the HTML and of the commerce landing page based on the hand-drawn sketches in the image. So we are sending textual prompt, and we expect to get a code snippet for the website UI back. And that's exactly what we should get as a result in a few seconds. Yeah, we're still waiting here. Sorry for a few connectivity issues. By the way, I will show an example that I have done already. Basically, what I've got use test. So these produced by this kind of combined input textual prompt plus image. And if I look at the preview of my web, I got something depicted in my sketch note. So I have my title, Conto's Outdoor Company, and then I have my pants, backpacks, hiking clothing, and as you can see, I get some placeholders for the images in a way that I basically have my website UI skeleton out with my images, which is already, you know, a good starting point for my website design project. Cool. Now let's come back again and let's go. By talking about inputs to the model, we can't avoid talking about data, because data is the fuel for AI in general and for generative AI also. But activating data has many challenges. Data complexity for one, especially as data sources are more multidimensional and not just structured. And while models are evolving quickly, data is generating faster, making it hard to ensure you're surfacing the very latest information available. And the other knowledge gap these models have is about all the data protected by firewall that they cannot access. But differentiation to us is about the grounding and customization, which separates high-performing generative experiences from others. So how to achieve these differentiation through custom data? We can rely on an architectural design like retrieval augmented generation to include grounding data into a large language model prompt. Because by looking at the prompt components, we said we can provide the model access to private and or fresh data by adding the information into the prompt. But the thing is, the data we provide to the model should be relevant to the user query, so dynamic, and also limited in size, because larger the prompt, higher the latency and the pricing of the call. So here's where patterns like retrieval augmented generation comes into play. This architecture pattern enable to store custom business data, retrieve relevant data to the user query in an optimized manner, and then use the result to inform the large language model prompt. So the way it works is the user inputs an initial prompt, which is used to search a data source and retrieve relevant grounding data. The grounding data is used to augment a prompt by adding additional contextualization and scoping text. And the augmented prompt is then submitted to the large language model, which can then generate an appropriate response in natural language. Now, the data relationship plays a central role in applying retrieval augmented generation effectively. And here are just a few of the best practices we should implement to make the most out of retrieval augmented generation. First of all, chunking. So preparing data to ingest into the data pipeline by splitting our documents into more efficient and manageable pieces, which are called chunks. Vectorization, which is another data preprocessing step that creates encoding to represent our data chunks in a numeric format in a way that the model can process this data more easily. And we can also get a common basis that the search engine can use to match on vectors that are most similar to the user query, with no requirements for matching on exact terms, language, or format. And then we have the indexing, the search index concept, which describes how your content is organized to make it searchable. You can imagine a library containing many books, and you want to be able to search through the library and retrieve the relevant book easily and efficiently. So to make library searchable, you create a catalog that contains any relevant data about books to make any book easy to find. So a library's catalog serves exactly as the search index. And then we have the ranking, which is the last phase of the retrieval process. So once you get a list of relevant results from your search, you want to order the resulting chunks in a way to prioritize them based on deep meaning. Now, this might look quite complex, and it is, but Microsoft is focusing on simplifying the process of connecting your AI solution to your data and formatting it correctly. So to get the best-in-class search service in Azure, you should go with Azure AI Search, which provides the infrastructure and tools to create search solutions that extract data from various structured, semi-structured, and non-structured documents and index them, enabling optimized search over several Azure data sources, but also third-party data sources and on-premises files. However, it's not the only option you have in the Azure ecosystem. If you already have your data stored somewhere like Azure Cosmos DB or SQL DB, you can also keep your data where it is and leverage the built-in vector extensions to perform vector search across your data. No matter which option you choose, in the Azure ecosystem, your data is protected by the most comprehensive enterprise compliance and security controls. And your data is your data. So when you build your AI solution on Azure, you build on trust. Since Microsoft doesn't use it to train our foundation model, we don't do anything with it. Data is kept secure and remains in the same region you have selected, reflecting Azure's commitment to data security. Well, we covered model discovery and model differentiation through techniques like prompt engineering and retrieval augmented generation. To put all these pieces together, you need an AI orchestrator tool to streamline the end-to-end development lifecycle. And in the Azure ecosystem, you can rely on Prompty. Prompty is a language-agnostic prompt asset class and format for creating prompts and engineering the responses. It has three main components. The specification, which is a standard format that unifies the prompt and how it is executed into a single asset. The tooling, which is basically a Visual Studio Code extension, including things like syntax highlighting, variables validation, but also more complex stuff like code and evaluation generation. And then we have the runtime, which is the Prompty runtime used to execute the app logic. So it's the Prompty engine that understands the Prompty file and execute the format. Let's now build a simple app for our website designer scenario and add our data to our app using Prompty. So for that, let me jump to Azure AI Studio again, because what I've done is I have already uploaded my data to Azure AI Studio and connected it to my Azure project. So this is my data. Let me see if I can, no, sorry, this is the index. I want to show you the data. Here we are. So I've uploaded this product.csv file, which is basically, as you can see, a list of a products catalog list with information about the products. So name, price, category, description, and so on and so forth. And then what I've done is I've basically built an index on top of this data to leverage Azure AI Search capabilities to optimize search across my data. So what we are trying to do here, since in the previous demo we used GPT-4o to generate website copies and other assets without providing any specific context for, sorry for that. So in the previous demo, we used GPT-4o to generate website copies and other assets without providing any specific context for our Contoso e-commerce website. Now we are going to do one step further and providing our model access to the e-commerce products catalog. In a way, it can generate more relevant content for our website. So let's see how this data is used alongside my GPT-4o model instance in my solution by exploring my application source code. And I will give you the link to this repo at the end of the session. So all the app source code is stored in this Web Designer app folder that includes 2 main files. One is the .prompty file that defines the model configuration and the prompt specification. So at the top, you can see that you have the model configuration, some metadata, and also an example of the input format. And then we also have the system message. As you can see here, we're using some placeholders, some variables for the context and the question that will be filled out at runtime. And then we have a Python script, which basically contains the application logic, which is responsible for a few things. So let's go to the key function here, which is the get response function. So what this application is doing is it converts the user query, which is passed as input, into an embedding using the text embedding ADA 002 model. It then uses the question in raw text and embedding to perform a hybrid search in the product catalog index I've showcased to you in the Azure AI project before. And then we are going to load the prompty file I have showcased to you 1 moment ago. And it executes it by passing the variables that should replace the placeholders we had for the question and the context. And then it print out the result to the console. So to execute our application, what we need to do is just basically executing my Python script. And this is printing out the context retrieved from the products catalog. So you can see here from the product.csv file, it is extracting the chunks relevant to the question, which in my case is create the website copy for the 10th catalog page. So if you see here, I have specified this question. And then it also, it is giving us as output also, it is printing out to the console also the final output, which is exactly what I've asked for. So the content for the 10th catalog page. But there's a better way to visualize all of these and also the intermediate step by using the Prompty Visual Studio Code extension and specifically by looking at the traces UI. So in here, you can inspect the input to the application. You can inspect the output in a better format than just a printed string to the console. And then you can also inspect the basically the intermediate step. And what we can notice by looking at the output is that this time the output is grounded into the products catalog, because the products it is mentioning in this website copy are real product existing in the products catalog. So we achieved our goal basically. Cool. Let's go back to our slide once again. Because the last piece I want to cover in this session is about evaluation. Because once you have built your website designer prototype or your prototype in general, the next step is how can you tell that the application is good enough to be operationalized and then released into a production environment? And the answer is exactly using the evaluation process. However, there's a few factors to consider. We need a way to measure if and how the answers from my system are incorrect, irrelevant, or even harmful, because they contain, for example, offensive content. We need to face new attack methods that are emerging that ingest into the prompt harmful content that can let the system behave unexpectedly. And we need to define new metrics with respect to classical machine learning scenarios, because foundation models have no reliable source of truth. for their stochastic nature. So we cannot easily compute the distance between the predicted and the actual value and get an accuracy, basically. So evaluation is an ongoing process of trial and errors, and the introduction of generative AI models led to a completely new way to evaluate an AI system. The approach here is we take a test set, so a bunch of inputs to test, we run them through the system, which generates some outputs, and then we evaluate those outputs against one or several predefined metrics, which will give us a performance score, so a level of quality. And the evaluation can be manual, so we have human agents inspecting the outcomes of the test and evaluating how well the system responds for the given input. But it can also be AI assisted, which means we use another generative AI model to score the quality of the responses given the AI system. And the two are complementary process because the first is important to ensure an accurate validation, and the second is very helpful to scale the testing process. Now, this process is not done once for all, but should be redone every time we implement a change or improvement that we found necessary thanks to the previous evaluation process. And there are several metrics to evaluate our solution from a generation quality viewpoint, but also a safety viewpoint. For example, we can check if it contains sexual arms, toxic language, and so on and so forth, bias. But for the sake of this session, we are going to focus on the generation quality performance. So here's the metrics we are going to use to evaluate the application we have built in the previous session. Groundiness, which measures how well the model's generated answers align with information from the input source. Relevance, which measures the extent to which the model's generated responses are pertinent to the given question. Coherence, which evaluates how well the model can produce output that flows smoothly and resembles human-like language. And fluency, which evaluates the extent to which the generated text conforms to grammatical rules, so it is basically grammatical and syntactically correct. So let's go to our last demo of the session, which is about evaluation. And for this demo, I have created a Jupyter notebook. Again, this is available into the repo that I'm going to provide the URL to this repo at the end of the session. We are going to evaluate the performance of the prototype we have built in a previous demo. So this notebook performs the evaluation against a sample test dataset that is available in the repo as well. It's a very simple one, just 3 questions. One is create a website copy for the TENS catalog page, the one we have tested before. And then we have another couple of questions asking for a sleeping bags web page and the hiking shoes web page. So using this test data set, of course, we configure our Azure OpenAI model, which will be used for the AI-assisted evaluation. And in this case, we are going to use the GPT-4 model instance. We're going to configure the test data set I've showcased to you right now. And then we are going to import the class evaluator for the metrics we have just defined. So relevance, groundiness, fluency, and coherence. And then what we do here is we run the evaluation by specifying the test data set, the target function we want to evaluate, which is the get response function specified in our Python script, the evaluators we have just imported, and the evaluator configuration. So we are going to map the question with the questions inside the test data set, and the answer and the context with the output of my application flow. And then I'm going to push the results to my Azure AI project to visualize the results into Azure AI Studio. So I've already launched this evaluation because it takes a few minutes to run. And here's the result. I've printed out at console the result. But as I said, we can better visualize these into AI Studio. So let me showcase directly the results in the studio. And what we get in here is a metric dashboard. So basically an aggregated average score per each metric across the whole data set, but also some detailed metric for each pairs of question and output, in a way that we can also inspect exactly where the model performs well and well it doesn't. Great. This was for evaluation, and basically almost what I have for today's session. So let me jump back to the deck to kind of wrap up what we have seen today. We have seen basically Azure AI platform, and we have used it to for a real-world use case. So to build our first generative AI application for creating basically a creative assistant for our new Contoso e-commerce website design. And we have seen as Azure AI is basically the platform that gives you everything you need to build generative AI experiences that scale. We covered the platform, the Azure AI Studio, and the features to be productive with AI. We covered prompt engineering and some techniques that can help us get accurate responses. And also we have seen how to use retrieval augmented generation in Azure AI Studio to add a data source to our application. And then we have seen some tools created to help you fine-tune and evaluate your AI models and the response they produce. Now, the learning journey doesn't stop here. So I want to give you some sort of homeworks. If you want to keep learning and continue your learning journey, you can, if you are a Discord person, you can join a worldwide AI community of like-minded peers of AI enthusiasts. So you can use this link to join directly this AI Discord community. You will find Microsoft MVP, you will find Microsoft FTs, so people from my team, people from product groups, and so on and so forth. Or if you prefer, to check if there are any in-person events close to you, or any meetups, any community kind of events in your region, I really encourage you to visit globalai.community. It's another worldwide wonderful AI community of wonderful people, enthusiasts, of AI enthusiasts. And again, you will find lots of Microsoft MVP community in this global AI community too. And then, as I promised it, this is the repo where you'll find all the code I have presented today, and also all the instruction to set up your AI environment in Azure AI Studio. So feel free to replicate the demos at your own pace. You will find all the instructions in here. And with that, I would like to wrap up and thank you all for watching this session. Thank you. Bye.